This video I'm just going to do two Hardy-Weinberg practice problems. The allele y, lowercase y, so that's the recessive allele, occurs with a frequency of 0.8 in a population of clams. Give the frequency of all three genotypes. Okay. So I know that this frequency that it's telling me, because this is the recessive allele, not a genotype, that's going to be Q, is equal to 0.8. And so I know that because of P plus Q equals 1, that if Q is 0.8 and it has to add up to 1, P must be 0.2. Okay? So I'm just going to start with the genotypes. I know that the frequency of two capital Y's is also going to be, P squared. And I just square my P value there, so that's going to be 0.04. I know that the frequency of the heterozygote is going to be 2PQ. So that's 2 times 0.2 times 0.8. And that's going to be 0.32. And lastly, the frequency of the homozygous recessive allele, genotype, is going to be Q squared. So I just square my Q value, and that's going to be 0.64. And then just to check my work, because I know that P squared plus 2PQ plus Q squared equals 1, let me just do a check, and I'll do my 0.4 plus 0.32 plus 0.64 and see if that adds to 1. Sorry, that should be 0.04. And yes, it does add to 1, so all of these are going to be correct. The inability to taste PTC paper, which is going to be recessive, we see the lowercase t, let me put that in a color, is recessive to being able to taste it, capital T. At MHS, and this is just a problem that I made up, at MHS 243 out of the 2,000 students are unable to taste PTC paper. So unable, so that means they are homozygous recessive. Calculate the frequency of the homozygous dominant, the heterozygous and the homozygous recessive individuals. Calculate. So basically it wants me to find everything. So it tells me that 243 people are homozygous recessive. Out of 2,000. And so I can get Q squared from that. So I'm going to take my 243 and divide it by the total number of people, and that gets me 0.12-ish. I'm going to round. All right. And from there I can get Q, and I just square root my Q squared value, and that gets me about 0.35. From there, I know again, because P plus Q equals 1, that if Q is 0.35, P must be 1 minus 0.35, which is 0.65. I can then say that P squared is going to be the square of that. That's going to be 0.42 about, and then 2PQ is 2 times P times Q, which is 2 times 0.65 times 0.35, and that is about 0.46-ish rounded. And so again, checking my work here, I know because P squared plus 2PQ plus Q squared is equal to 1, I have 0.42 plus 0.46 plus 0.12, 0.42 plus 0.46 plus 0.12 is equal to 1. So I have found the frequency of the homozygous dominant genotype, the homozygous recessive genotype, the recessive allele, the dominant allele, the homozygous dominant genotype, and a heterozygous genotype.